everyone, this channel is about engines, so I've started a new series here about repairing this engine, about repairing this gearbox. So a subscriber came to me for repairs. Here's the car. It's an old Volvo from the 90s. My task is to repair the engine and repair the gearbox. Right now I'm starting by removing the gearbox. I've already disconnected the air hoses here. There's a whole bundle going to the gearbox, to the gear shifter. Basically this bundle goes there. I've disconnected the air hoses and now I'm removing the gearbox. Now we're taking the engine to the workbench and starting to take it apart. So we've already removed the oil pan from the engine. If you look, the engine is standing without the oil pan. So the oil pan is made of very thin sheet metal. For those who know, like the Zawod Imienia Lekaczowa oil pan or the Gorkowski Automobilny Zawod 53 with the MZAK 511. It's the same kind of thin metal and you can't really set it in place properly. It just bends right there. They removed the oil pan and the pickups. And here they laid out whatever they could find in a hurry. Some pieces of wood, plastic bottles. Basically, they laid it all out and brought it over. This is the workshop. Now the engine model and its technical specifications will appear on the screen. And later we'll also repair this gearbox. That's the scope of work we have, so let's get started. So I removed the fan and now I need to take off the gear shift lever assembly first. To do that I need to free up these air tubes, the bundle of tubes going to the gearbox. Okay. Here I've disconnected the air supply to the compressor, not the air outlet from the compressor. You can see that the compressor has a separate air filter and this is how it's installed. Now I'm removing this solo hose, taking off this air supply hose, pulling the bundle of air hoses to the side and removing the gear shift lever. be honest, these are my first thoughts, but they did offer to repair Machine and Fabric Augsburg, Nürnbergs and Mercedes, like take a Machine and Fabric Augsburg, Nürnberg or a Mercedes and just do everything as usual. No, I had to take a Volvo. The subscribers want variety. They keep asking on the channel, when will there be a Volvo? When will you take some other engine? Machine and Fabric Augsburg, Nürnberg. So now Machine and Fabric Augsburg, Nürnberg and Mercedes. I don't think it will have any effect on the channel. It's pretty much all the same. I don't know why I took it. Next, I need to remove the exhaust manifold, the intake manifold, and right now I'm looking at all this and getting upset. On the exhaust manifold, there are 4 bolts, but their placement means you can only reach some with an open end wrench. I don't know. I've never seen an engine where everything was done like this. Remove the manifold by unscrewing 4 bolts and taking off the cylinder, then remove 2 bolts, another 2, and finally 1 more. So, we see that we have access to this bolt, but it's not clear at all how to reach these 2 bolts. There's a bolt under the manifold here. I have no idea how you'd unscrew it. It's a complete mess. Plus, I can't remove the coolant manifold right now because I don't have access to all the bolts. I've never worked on a Volvo before and I probably won't do it again. Well, actually, I will after this engine because I have another engine, another Volvo, coming in. The deposit's already been paid. But after I finish this engine and the next one, I'm not taking any more Volvos. The bolt is installed here, but you can't remove it from this side. How did they even put it in? Apparently I need to knock out the spacer washer and then I'll be able to get it out. Alright, I won't record the whole process right now. I'll turn the camera back on in about an hour. So after I unscrew these 1, 2, 3, 4, 5, 6, 7, 8, 10 bolts, 9 actually. That should take about an hour. I used to think D245 was impossible, that no engine could compare to it, but it turns out there are even worse ones out there. So, it's all good. The D245 is actually a pretty decent engine. It turns out then just grab the wrench with your teeth and get started. here, damn. We could have come up with something like this, damn. I just... Seriously, just to remove it, to take off the manifold. In terms of time, effort, and inconvenience, I don't even know what to compare this to. Alright, that's enough filming. Yeah, forgive me, of course, Volvo owners, but everything here is done so thoughtlessly. So primitive, I don't know, it just reminds me of D245 reminds me of KMAZ 740, full of tubes, inserts, gaskets, bolts, and clamps everywhere. You definitely won't find this in Maschinenfabrik Augsburg, Nuremberg, or Mercedes truck. In Maschinenfabrik Augsburg, Nuremberg, or Mercedes, everything is completely different. Every little detail is well thought out. Here, everything is just... They just made it however it turned out. Let's put it this way. For example, the heat exchanger. Honestly, I don't even know what to call it. It's just sitting there separately. Some crappy thing with all sorts of tubes, hoses everywhere, clamps everywhere, mounts everywhere, brackets everywhere. You could list all this stuff endlessly. For example, let's say you want to remove the compressor. So it's a kind of mount that you can only unscrew with an open-end wrench, a box end wrench, and you can only break it loose the first time you put it on. Now it doesn't fit anymore. That's it, not to mention a socket or even a power tool and so on. So only with an open-end wrench. So there are moments like this everywhere. These little things are everywhere. That's it. The nut won't unscrew further. It's still on the stud, not off the thread yet, but now it's stuck against the housing. Right away. Another example, to remove it from the studs, you have to pull it this way. Here is one fitting, the second fitting, and a hose between them. The hose is about 10 centimeters long, with 5 centimeters of free space between the fittings. So you have to get the hose in here, get the compressor in here. It's a hopeless situation. Either you pry the hose out with a crowbar now, or maybe even cut it. Well, who knows, this is our general reference to the Ulinovsky Automobilny Zavod engine. To get to the push rods, you need to remove covers like these, or maybe there's one or two. I don't remember exactly. And the push rods are about the same as on the Ulinovsky Automobilny Zavod, just bigger. So, well, what can I say? I've opened up the cylinder heads for now. Visually, my first impression is that the cylinder liners are worn. The wear is significant. The liners are definitely due for replacement. As I said, the wear is significant but even. There are no deep scratches or similar damage. Regarding the engine block, I can't say for certain. Everything should be cleaned and inspected, but I don't expect any issues. At first glance, it appears to be in good shape. So what do I do next? Next, I need to remove the pulley. Take off the alternator. I don't know. Maybe I'll try to turn the engine over now. It's inconvenient. I couldn't turn it or install it when it was assembled. So now, I'll give it a try. And I also need to remove the fuel pump, take it out, and check the timing marks to see how the ignition is set. I'm removing the pump, taking off the alternator, the power steering pump, and the front cover. Then I'll check the timing marks and take them off. Next, we'll lay the engine on its side and remove the pistons, crankshaft, and other parts. So next I'm removing the fuel pump and I've set the timing marks. That is, on the pump itself we have a plate with a mark with a stripe, and also on the coupling, on the drive itself, there is also a plate. You can see I've aligned them here on the flywheel housing and opened the inspection window, and here we have about 24, 25, somewhere in this range, maybe 26, it's hard to see. The customer said he set the ignition slightly earlier. Ideally, this engine should have 19 degrees, but the customer has about 25, so it's 6 degrees earlier. I don't know, of course, we'll see during assembly, and we'll send the fuel pump for inspection. If this stationary mark here hasn't been moved, meaning it's in the correct position, then we'll probably set it. It's not 25, but maybe from 19. A couple of degrees earlier, maybe 21. I think somewhere in that range, but that's just my thoughts for now. Later, of course, we'll see how things go. Alright, I've lined up the marks. Now, I'll start removing it. I'll see whether we need to unscrew these bolts or those ones. We'll figure out what's better. And also, the pump mount is these 4 bolts here. So, this is our oil drain, right? The drain. There should probably be an oil supply somewhere else. The drain. Yeah, here we probably have the oil supply under pressure, and this is the oil drain, the drain. Everything here is covered in oil in the flywheel housing, and it's not clear. It even seems dry under the oil seal for some reason. But right under the flywheel there's oil, and here, like a dust cover, there's oil coming from under the dust cover. It's still unclear where the oil is coming from. It appears to be running down the bolts or possibly being splattered. Well, of course we'll have a new oil seal, and maybe somewhere behind the dust cover there's some kind of gasket there. Maybe the oil is leaking from under it. Alright, we'll keep an eye on all of this and pay attention to it. So it looks like we still need to remove this hub, this one here. Apparently the crankshaft itself has this kind of profile, so this tailpiece is shaped like a triangle. Yeah, so it turns out I need to use a puller now, hook onto the thread or something, and only then will this cover come off. We can see there are a bunch of gears here. 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10. 10 gears in total. This is the crankshaft, and this is the camshaft. This is an intermediate gear. This is the drive for the fuel pump. This is another intermediate gear. This is the drive for the water pump. This is the drive for the power steering, and this is the drive for the compressor. This is another intermediate gear and the drive for the oil pump. So now I'm wiping everything down, setting the marks, checking the timing. Well, here it's probably just like on the D245, like on the Maschinenfabrik Augsburg-Nürnberg D08-26. The intermediate gear won't come out right now. According to the marks, you have to make a lot of turns here for the marks to line up. Well, let's take a look at it now. Maybe we'll take it off and move it over. So, we're only interested in 3 gears. The crankshaft, the camshaft, the fuel one, plus this intermediate one. Well, 4 in total. All the others, they go on without marks. Well, basically we can see here's the crankshaft mark, here's the camshaft mark, and here's the other mark, the fuel pump. Well, here we have a mismatch. This one is the fuel one, and these two should be right here. Well, basically everything is clear. You don't even need to display it. It's all obvious and understandable. Did anyone else notice how I'm struggling with these bolts? Yes, so on this engine we don't use the metric system, but the imperial system, meaning all the bolt heads are in inches, and all the threads are also in inches. That's why I don't have an imperial set, because I'm metric. I've never worked on an engine like this before, so this is actually my first engine of this kind. So I work with metric sockets. This is how it should be. As we can see, the crankshaft is aligned, the camshaft is aligned, and the fuel timing is also aligned. So, about the gear, what I want to say right away is that inside we have this kind of bushing, and we can see that it's starting to crumble. I don't know if this bushing can be replaced separately, or if the whole gear assembly needs to be replaced. We already have something similar, such a problem. Well, the axle is in good condition. So it looks like the thrust washer has come apart, as we can see. On this side there's noticeable wear. I don't know if it's possible to try sanding it down or maybe replacing it, but the wear is quite significant. Alright, now I can take out the thrust washer, but first I need to remove the push rods. I'm taking out the push rods, then the thrust washer, removing this front cover. I'm not touching these gears. I'll leave them as they are for now. Then I'll remove the cover, the block, turn it on its side and take it out. The pistons. So the push rod is this kind of cap. Just like I said, it's like the Gorkovsky Automobilny Zavod 53 motor plant 511, only a little bit bigger in size. So as we can see, the push rod is worn out. The push rods will need to be replaced. Well, here we can see that, for example, on the first cylinder, the push rod is very badly crumbled. Usually, if the push rod is in this condition, the camshaft journal also suffers. The camshaft lobe acts like an abrasive, and this abrasive wears it down. So now let's take out the camshaft. The camshaft lobes show visible wear. The question is, how much are we going to measure to see how much they differ from the standard? Camshaft lobes. So the camshaft lobes are still in pretty good condition. The size is standard. The bearing that's inside the connecting rod is definitely in worse shape. And as we can see, it's been crushed, so it's loose. There might be some issues with the connecting rod. You can clearly see that the rings are really worn out. I'll take one off now and measure it. And also the pistons have scoring on them. So the piston assembly needs to be replaced with a new one. This is what it looks like. And now we're immediately measuring the ring. The gap is about 3/1/6 of an inch, which is a lot, about 10 times more than normal. The main bearings are also in, let's say, satisfactory condition, but you can also see that they're not holding up well. That means it also got crushed. And I also don't like this shine on the cap itself. Maybe? Alright, let's take it apart and see. So that means we see on the second cylinder, the sleeve was removed. They applied sealant here. And basically the rubber ended up with these patches from the sealant. My engine is disassembled. Let's summarize the initial results. So, about the camshaft first, we'll look at the camshaft bushings. The customer said the pressure is good. I'll clean them and check. But for now, I don't know about the bushings. As for the camshaft, like I said, some of the lobes are worn down. These ones here, they're all exhaust. I took measurements. And this one is the worst lobe, while this one, you could say, is in perfect condition. The difference in height is about 0.6 mm. Well, I don't know yet. We'll still have to check these two. First, we'll check the price of a new camshaft. Then see if it's in stock and if the parts are available. And everything will also depend on the customer's wishes. If he says he wants a new camshaft, then we'll order and install it. If he says no, we can leave this one, since the car isn't new. How much longer will it last? 3, 4, 5, 6 years. For that period, I think this camshaft will be enough. As for the crankshaft, most likely, we won't do anything with either. I took a preliminary look at it. There's a bit of wear here, some scratches. But I think it's better to weld. For example, you can see it clearly here. I think it's better to have little wear. Let it be slightly undersized rather than grinding it down to the repair size. That's my opinion, and I've installed them that way multiple times, using -0.06, -0.05, 0.06, and 0. In general, everything works fine. Grinding is challenging because you must keep all dimensions and create the fillet. And ground crankshafts break more often, so I think we'll leave the crankshaft and camshaft as they are. As for the piston group, it definitely needs to be replaced, that's for sure. There are scuffs like this on the pistons, scratches here and so on. So the pistons, rings, sleeves, all of that needs to be replaced. the piston assembly as a whole. And of course, the seals and the piston pin is included in the kit, so all of that will be replaced. I can't comment on the engine block yet. It must be cleaned and measured first. There are concerns about the crankshaft bearing seats. As I said, we'll clean it and check. It's possible, not out of the question, that the block will need machining, but that's not certain yet. Also, the mating surfaces of the cylinder head and the engine block, as well as the seats for the liners. We'll check that after washing and cleaning and make a decision later. We'll disassemble the heads and check the condition of the seats, valves and guides. It's possible the heads will go for surface grinding. Of course, we have this feature here, this ridge that sits on the sleeve. Well, we'll see, but most likely the heads will go for surface grinding. So, the turbocharger and the fuel equipment will also go for inspection. After the inspection, we'll decide what to do with them. We'll also take the electrical equipment for inspection, the starter and the alternator. The pump will stay as it is, since the customer recently installed a new one. Well, the compressor, where is it? The compressor anyway, the compressor is somewhere here. We'll repair it, open it up, check it out. That's what we'll do with the compressor. The compressor has a feature, its cylinders are non-removable. You see what's going on here. If there's wear on the cylinder, you'll have to buy a repair piston and bore out the block itself, the housing. Well, we'll see about that too. We'll get to it later. As for the clutch, I don't know yet. We'll see about the clutch. So now I'll make a list, get in touch with the customer, and we'll decide what to do and what not to do. Then I'll keep cleaning up. Some things we'll send for machining, some things I'll handle myself, like disassembling the cylinder heads and so on. Some time has passed. I've already cleaned the engine block. And what I want to say is that the block will definitely go for machining. That is, the cylinder head mating surface definitely needs to be ground. We can see these kinds of pits, these holes. Also, machining the seats for the liners is a must, that's for sure. The seating surface is damaged and the main bearings. All of this will be done on the machine. The machinists will take measurements and then it will be clear, but I think we'll have to machine the bearing seats as well. So the block is already prepared. I washed it, cleaned it with a wire brush in diesel fuel in a jet washer, then cleaned it again with a wire brush, blew it out, so the block is now fully prepared for machining. Probably in the next few days, tomorrow or the day after, it will be sent out. Well, maybe I'll unscrew the drain tap now. Maybe I'll unscrew this elbow too, so it doesn't get broken, and that's probably it. So I also need to prepare the fuel equipment. The pump will be sent for test. Nu fac unchi with injectors. So now I need to remove this bracket. Remove the hoses with the filters and clean the injectors. The generator, starter and turbocharger will be sent for testing. Everything must be cleaned and prepared now. I need to remove the oil supply lines. The line was bent, so I need to remove the oil supply line and the oil drain line. I'll also clean it a bit, at least get rid of the worst dirt. I don't know, I'll take a look at this radiator and decide whether to remove it or not. Well, I also need to prepare the connecting rods for machining. So I need to remove them from the pistons, take out the bearings, clean them, and put the caps back in place. So What else do I want to say about this engine? E. While disassembling it, I noted some bolts were oddly installed and there were unusual construction brackets and adapters. E. Well, that's all true for the external parts, some mounts, bolts, adapters, rubber pieces and so on. That's all correct. It's inconvenient when it comes to the internals. E. I look at it and I see that there's a huge margin of strength here. E. So, just by looking at the connecting rods, E. You can see the diameter, or rather, the thickness of the wall under the piston pin bushing, and the connecting rod itself, E. The width of the rod bearing, the cross-section of the rod itself, and so on. Everything here is so robust, even more so than, say, on a Mercedes. If we look at the piston, you can see the length of the skirt. Nowadays, you probably won't find pistons with such a long skirt anymore. And the piston itself is so powerful and massive. Of course, that's definitely an advantage of this engine. Everything is so robust. Everything is built with a margin of safety. Journal diameters such as connecting rod and main journals, etc. So it turns out that this engine has its own advantages, but it also has its own disadvantages. So I'm starting the assembly. All the parts have already been purchased. The engine has already undergone machining. And as for the machining work, everything is standard. The cylinder head mating surface, the seats for the liners, and the saddles for the main bearings. So the block came back from the machining shop. I've already blown it out, got rid of the biggest chips myself. My task now is to clean out all the channels, remove the oil nozzles, take off some plugs where needed, basically blow everything out, clean it, and get the block ready for assembly. So today is Saturday, and the adjustment rings for the sleeve will only arrive to me on Monday. Let me explain briefly why that is. While we were waiting for the machine to be done, for the machinists to finish their work. So, as we can see here, for example, we have 0.3 mm for the 6th cylinder, so we need a 0.3 mm adjustment ring. Here, we have a 0.8 mm adjustment ring for the 5th cylinder. For the 4th and 3rd cylinders, we install them without adjustment rings, just a single sleeve. The 2nd cylinder needs a 0.3 mm adjustment ring. The first needs a 0.5 mm ring. Additionally, 0.3 mm was taken off the block at the cylinder head mounting surface. If we look closely, we can even see some small pits like this. They're really minor though. Overall, the mounting surface is basically perfect. So, what other problems does this block have? Well, since our engine is already old, from the 90s, I think it's from 92 if I'm not mistaken. This edge here is supposed to be sharp, but it's already pretty rounded. You can see there's corrosion here, and there's nothing you can do about it anymore. It's basically beyond repair. So what am I going to do about it? Well, of course, I will do something. We've installed a new gasket, and I'll apply sealant. I'll put on a good amount of sealant and press the sleeves down so they stay clamped for a day, so the sealant dries in the right position and the sleeves fit better. I don't have an answer or any other options for what I can do. Well, I think we shouldn't have any problems. I think everything will be fine. So, that means I have Saturday and Sunday for some more prep work, like I said, to work on the block. Do some more prep and work on the head. I still have things to do. By the way, you can see these rusty cylinder heads. We took them for pressing. Here, I replaced one injector sleeve. Plus, I needed to check the 2nd cylinder. The customer had complaints about it leaking. That's the issue. Basically, I don't have the ability to pressure test these kinds of cylinder heads. We sent them to an outside company for pressure testing. They were in perfect condition from Pescostroy when I had them, but when returned, this is how they look. So it turns out they do the pressure testing there just in ordinary water, and obviously they all end up rusty afterwards. I don't know, now I have to do something about this again. But okay, these are just little things, details. The organization that repairs cylinder heads and engine blocks also does pressure testing and replaces seats, guides, and more. And that's the kind of attitude I get to. I don't understand really what's going on. Well, couldn't they have used some kind of sealant or a lubricating cooling fluid? I just don't know. The fact is, I have to do something with the cylinder heads now, and they're in this condition. So here's what else I need to do with the cylinder head. I've already lapped the exhaust valve here, replaced the guides, and lapped the exhaust valve. And I still need to lap the intake valve, since I haven't had the intake valves yet. Since the cylinder heads went for pressure testing without a lapped valve, I still need to lap 6 valves on these heads. Everything else is basically ready. I'll explain and talk about things as I go. For example, I opened up the oil pump to check its condition. I also opened up this intermediate gear. We have a new shaft on the gear and a new bushing installed. The bushing on this gear has also been replaced, although it's a used bushing since we couldn't find a new one. We bought a used gear like this, but I didn't really like the gear itself. The old gear is actually better. So I took the bushing from this gear and installed it on the original gear. And as for this intermediate gear that goes to the oil pump, there's this kind of wear on it. On the shaft itself, I don't know how well you can see it on camera, but it's really deep here, about 3 or 4/10 of a millimeter. And this shaft is from the company Lassa, so it was replaced at some point. I don't know when the repair was done, but it was replaced at some point. So a new shaft has been installed, and a new bushing has also been installed on the intermediate gear of the oil pump drive. Also opened the fuel pump drive, replaced bearings and oil seals, installed new rubber seals and set them with sealant. That is, a lot of work has already been done. A bit later I'll insert some footage I have of the preparation work. I did some things off camera. Everything is already cleaned, sandblasted and ready. Also we had the fuel system repaired, the pump, the injectors. We also had the turbocharger and the electrical equipment repaired. Also, for example, the casing was welded. When I took it apart, or rather when I washed it, I found cracks in these spots about 8 centimeters long. We took the casing for argon welding. Now my task is also to smooth it out a bit here, especially in this spot. As we can see, the weld has gone right on the mating surface.
Basically the same goes for the casing.
Also, let's say there's some other work to do. For example, installing new studs. New studs have been purchased. One here was broken and some are stretched out, so I already have the gearbox from this car ready. I don't know which series will come out first, the one about the gearbox or the engine. The gearbox is already completely finished, painted and ready to be installed. So now, you'll see some footage of the preparatory work I filmed for this engine. And then, as I said, we'll work on the block. Let's get started. Alright, so I'm taking apart the cylinder heads, and on the second head the exhaust valve has this kind of play. Well, the customer did mention there was a problem with the second cylinder. He said coolant was leaking outside through the head, but as we can see, it's not just the coolant leaking here, the valve guide is also damaged like this. Interestingly, the customer had no complaints about power or performance. It was really interesting how, with such play in the exhaust valve, everything was still working. Yes. The valves need replacement, for example, due to excessive play in the first cylinder. But the valve itself is already worn out, meaning the valve stem is eaten away. So the valves need to be replaced, and the guide bushings also need to be replaced. And another interesting thing is that there are no oil seals on the guides. I've seen this on some Maschinenfabrik Augsburg Nuremberg engines. They also don't have oil seals from the factory. And as we can see, this engine doesn't have them either, just a bare guide. So I'll see if I can find some seals that fit by size, and of course it's better to install them if possible. So I also checked that our springs are the same. Sometimes there are differences. The NE, for example, the intake and exhaust springs can be different in height or the number of coils, and they are installed in a specific direction. Well, you can't just flip them this way or that. Sometimes they differ by color. But here we see that our springs are the same. So next I'll be assembling the compressor. As for the compressor, things aren't really that bad. There's almost no wear. So the crankshaft is in excellent condition and the connecting rods are in excellent condition. Well, now I'm going to take apart the cylinder head, check it and rebuild it. So what kind of compressor repair are we going to do? I'll install new piston rings. Here are 2 sets and a gasket repair kit. Here we have gaskets, valves, and everything else stays old. The piston pin crankshaft connecting rods, piston cylinders. Also here we have non-removable parts. Well, most likely there are oversized pistons available, so you can bore it out to a larger size and install repair pistons. But in our case right now, we don't need that. So that's the scope of work for the compressor. Let's get started. Next I'm assembling the head. I've washed, cleaned, degreased everything and replaced the valves. This is how the old ones are simply removed. They're threaded and I installed new ones. And they're fastened with a bolt, meaning the head is tightened together. 2 bolts are screwed into these valves and as a result they're pressed in there. So I replaced these valves. Now I'm installing new gaskets, new intake valves and putting it all back together. So, the block is still at the machine shop, but I should have it back in a few days. As you can see, my transmission is still disassembled. There are some issues with the parts for the transmission, so I'm waiting. Also, the block has been at the machine shop longer than expected. Overall, this car's repair is also going slowly. Well, I don't know, that's just how it is. Right now, I want to unpack the piston assembly. One of the sleeves is also at the machine shop with the block for measurements from the block's mating surface. We removed 0.3 from the cylinder head, so what should I do now? I want to machine each piston, trim them by the same 3/10. Well, about 35 hundredths, maybe up to 4/10, somewhere in that range, so that my pistons are ready. Because every time I take measurements, I keep thinking that maybe it'll work out and I won't need to trim the pistons. And every time the measurements show me that the exact height that was removed from the cylinder block's head surface is exactly the height I need to remove to trim the pistons. So now we're unpacking, taking measurements of the piston rings, checking the thermal gaps in the liners. Then I take each piston one by one to the lathe and trim them individually. I'll take measurements. Basically, I won't be filming this whole process. I've shown this on my channel before. I'm preparing and installing the pistons onto the connecting rods. So this is our heaviest piston, 4.869, and it turns out this one I think is our lightest. Yes, 4.856. The difference is about 13-14 grams, including the piston pin, rings and cap, out of a total weight of nearly 5 kilograms. The literature states up to 100 grams difference in piston weight is allowed. We have 13 grams, so everything is perfect. So, practically under every video people ask, well, of course there are different viewers, but still, under every video there's a question, how is this size restored? If I machine it, it becomes bigger. So I'll explain in a few words. We can see that the caps are also ground down. meaning they remove material from this spot on the cap, set it deeper, and as a result this hole becomes oval shaped. So in this spot the size doesn't change. If we look at the cap, the cutter only makes contact at this spot. We still have the old part left here, the remaining old surface after cutting. On the rest of the lid surface we can see that it was cut with a cutter. So the hole becomes oval shaped. They align it according to this measurement and take this as 0. So only the cutter touches the block, and basically the cutter mainly removes material from the lid itself. As a result, they achieve the desired measurement. Right now we have the perfect size here, according to the manual, just as it should be, and also perfect geometry, meaning there are no slopes, tilts, ovals, and so on. So this is how they restore it. They restore these seats for the main bearings. So the block is prepared and I'll start assembling. As I said, I don't have the adjustment rings yet, so I'll assemble what I can for now. So now I want to install the camshaft, put in this thrust washer, maybe install the front cover, or maybe I'll install the crankshaft first, then the front cover, and then I'll probably move on to the cylinder heads. We'll be using a new camshaft as I showed before. There were some questions about the old camshaft, but after checking the price, the customer agreed to buy a new one. That's the camshaft that was installed in this engine. It also wasn't the original one, it was from the original equipment brand, if I'm not mistaken, or BF. So it was also replaced at some point. This is a camshaft from the new original equipment brand. There will also be a new camshaft gear to replace the old one. There are issues, the teeth are chipping. So next I'll be installing the crankshaft. My crankshaft is already prepared. I clamped it in the machine, polished it, unscrewed it, and here are the plugs, these kinds of plugs. So this is also a reference to made engines like the Zavod, Imre Likachova, 130 Zavodski motor plan 511 and so on. But there in the journal we have a large cavity, so that all the dirt, any shavings and so on, accumulate there due to centrifugal force. Here we just have drilling, meaning the channel is drilled from the connecting rod journal to the main journal, and there's a plug installed at this point. But when I unscrewed these plugs, there was also a large amount of this black dirt, dry and compacted. Anyone who's taken apart crankshafts knows what I mean. I had to clean it out with a drill here, because the dirt was so compacted that I couldn't get it out with an awl or anything else. So I cleaned out all the channels with a drill bit, then used a brush on a drill to clean all the channels as well. Then I blew them out and washed them with a special solvent. The crankshaft is fully prepared. All the channels have been checked, all the channels have been cleaned, and this is roughly how they look. So I polished the crankshaft at the tail end where the oil seal is installed, and this is the kind of wear you get from the oil seal. Well, You can't do anything about that now. I'm not sure. I'll try moving the oil seal about a millimeter in either direction and see what works. So as I mentioned during disassembly, the crankshaft has some minor wear. It is okay. There are some small scratches here and there, but I took measurements and it's about 0.04 millimeters under, 0.03 to 0.04 millimeters under. Well, like I said, in my opinion, it's better to leave it with a little wear than to grind it down to a repair size blow. Alright, now I'm going to install the plugs with thread locker. Then we'll unpack the bearings, unpack the new thrust washers, and install the crankshaft into the block. So I tightened the crankshaft with the impact gun, laid the engine on its side, and now I'm going to torque it with a torque wrench. According to the manual, the bolts are tightened with a force of 340 Newton meters, plus or minus 25, so that means from 325 to 365. I'll tighten to the maximum, set it to 365, and tighten without the extra 90-degree turn. So I tighten to 365, and that's it. Alright, the crankshaft is tightened. I'm making these marks just for myself, so I know that these bolts are tightened. That's it. So next, I'll probably install the front and rear covers, and tomorrow I'm waiting for the rings, so I can install the sleeves and pistons. Then we'll close it up, hopefully tomorrow with the oil pan, or at least the day after tomorrow. So I finally got the rings. We offer rings in 0.2, 0.3 and 0.5 millimeters. I placed one ring of each size, and on the fifth cylinder there are two rings, 0.5 and 0.3, totaling 0.8. This one has no rings. I already showed and discussed all this. So I installed the sleeves without the rubber rings, installed the rings where they should be, already took the measurements, so everything is just perfect for us. So according to the manual, we look at the profile of the upper part of the sleeve. The protrusion above the cylinder block joint should be 0.47, 0.52 millimeters. So here we have this block. This is the sleeve, this is the flange, and the size is 0.50. Well, roughly speaking, 0.5 millimeters. So why did I do it this way? This flange fits into the cylinder head. Here's the groove I showed earlier. The gasket is initially flat, but when you tighten the head, this flange presses the gasket into the recess on the head. You get a lock formed by the gasket body, which deforms and is pressed from both sides. That's a really interesting solution. I don't think I've seen anything like it before. Now I'll show the cylinder liner protrusion on camera. Then we'll take out the liners, install new seals, and put the liners back into the block. By the way, as I said, I'll be putting the upper seal on with sealant, so now I need to figure out what I'll use to press it down.
All the liners, meaning at least each liner in two planes at 2 points, I'll clamp it, install it, and leave it until tomorrow so the sealant can set and dry. So first I'll show it on the unclamped liners, and then we'll clamp a couple of liners and see how much the value changes, if it changes at all. So as you can see, the block is at 0. Switching to the liner, it's 0.50 millimeters. Block is 0, liner is 0.50.
It shows 0.52 to 0.54 millimeters on average, depending on where you measure due to the ridge. If the liner isn't clamped yet, we'll clamp it and then we'll continue from there. Next, the block. Here we have liner 0, 0.54. Next, the block here is the sleeve is 51, then the block is 0. The sleeve is 50, 0, 51, 52. Fifth cylinder, block 0, sleeve 53. Sixth cylinder, block 0, sleeve 53. Well, now we'll tighten a couple of sleeves and see how our values change. So let's look block 0, sleeve 50, 300ths, block 0, sleeve 50, 300ths. So I installed the sleeves yesterday, turned them down. They've been sitting here for almost a day now, but I haven't touched them yet so that the sealant dries well and sets properly. I decided to work on the cylinder heads for now. I mentioned before, the exhaust valves have already been lapped, and I've marked which valve belongs to which cylinder head here. You can see the imprint from the seat, and now I've unpacked the intake valves. Everything is prepared here as well. The seat has been reamed, so now I'm lapping the intake valves and assembling the cylinder heads. This will probably take me the whole day today. The block will remain as is until tomorrow, when I'll install the pistons and close the cylinder heads in the morning. Everything's ready. The cover and oil pan. I think I'll close the oil pan tomorrow. So, yesterday I spent most of the day lapping these 6 valves. Not the entire day though. I didn't film the second half of the day. Did everything off camera. So the valves are already lapped, and I've prepared the keepers, springs, retainers and washers. So, as I said, we don't have any valve stem seals here on these heads, and I couldn't really find anything that would fit by size. So, we'll assemble it as it should be, without valve stem seals. Well, the guides are just perfect right now. No play at all. So I'm assembling the heads, and finally we'll be installing the pistons. I've installed the pistons. Now I'm going to tighten the connecting rod bolts. The bolts are tightened according to the following procedure. So the first phase is full. The second phase is 7.575 Newton meters. And the third phase is an additional 90-degree turn. I'm measuring the piston protrusion above the cylinder block now. The block is at 0 and the piston is at 0.20. That's how it is. The block is at 0. Well, it's not 0 here. It shows about +1. And here it shows around 18 or 19. Well, roughly speaking, it's 15 or 20 hundredths there. Next we look. The block is at 0. And the protrusion is the same, 18 hundredths. Yeah, I've already measured all the pistons. All of them have a protrusion from 15 to 20 hundredths according to the manual. The block, well, according to the manual, we have a protrusion here. Relative to the mating surface, the maximum is 0.55 millimeters. So I wonder if the lower limit is specified or not. But usually, as far as I know, everywhere the value goes from 0 up to some size. So here, I think it's also from 0 to 0.55 millimeters. Let me remind you, our average value is 0.2 millimeters, which is within the normal range. So next I'll be installing the cylinder heads, and I've prepared the gaskets. The gasket itself is just a plate like this. A plate with holes, with no seals, ridges, or similar features. So it's just a plate. Also the kit comes with a box like this. And here we have these little bushings of different diameters. So this is a bushing for the channel where the rod goes. This one is for the channel of the outgoing fluid. And the smallest one is for the oil channel supply. And there's also this pack here, which has a huge amount of rubber parts. So I've installed the gaskets and this is how it looks. So each cylinder head gets 5 of these bushings and rings, which means my cylinder heads are also prepared. Here, as I mentioned, I replaced one copper injector sleeve. So here it is on the first cylinder. I don't know how well you can see it on camera, but the new sleeve is installed. So after that I had the cylinder heads pressure tested. During the pressure test, they found one defect under one of the plugs. Basically one plug was leaking. So they opened it up on the spot, replaced the seal, screwed it back in, and did the pressure test again. So there are no issues with the cylinder heads either. Now about the cylinder head bolts and the engine block. This one. We have 16 old bolts left. That's 8 bolts per head. 16 in total. We're keeping the old ones. These are the original bolts that were installed at the factory. So I rejected these 16 pieces. As you can see, they have these pits, some corrosion, some more, some less. So these 16 pieces will be new, and the other 16 are bolts that were replaced at some point. So they're also made by the company Diagnostics
but they're still in good working condition. So we have 16 old Diesel Technica bolts, 16 new Diesel Technica bolts, and 16 original bolts that came from the factory. Alright, let's unpack the bolts and install the cylinder heads. Let's go, let's go. So I installed the cylinder heads and tightened them with the gun, just a little bit, not even up to 5k. Basically, I just set them in place and snug them up and got the wrenches ready. First, I tightened with the small wrench to 5 kg, then with the big one to 1.5 kg, and then the third phase, I think 19 kg, 190 N. And the fourth phase, we go up to the gate at 60 degrees. So it's interesting, right? Everywhere else, it's 90 degrees. For example, the same rod cap bolts are 90 degrees, but specifically the cylinder head bolts are tightened to 60 degrees. We'll stick to what's written in the manual. So now I'll tighten it to 190 and then up to the gate at 60 degrees. Yeah, it's very interesting. The bolts are tightened because the gasket deforms there, meaning it's pressed in by the flange of the sleeve. It's pressed into the head, into the recess of the head. So I tighten it, then go back to the first bolt again. And it turns out it still tightens those same 140. It still tightens. I tightened the sixth head to 140. Now I'm setting it to 190, tightening
then turning it 60 degrees with the wrench. So this one is 200 and this one is 190. Alright, I made marks at about 60 degrees and now we're tightening so that the marks line up. I was installing the cover and messed up. People often ask if I ever make mistakes. Show your mistakes, so I'm showing the seal. Okay, where is it? Where? The seal. Basically, I tore it. You can see it right on the working surface, like this. A crack. Well, this seal was included in the gasket set, meaning a full set of gaskets for this Erling brand engine was purchased. So the seal was included in the set, but for some reason there was no installation tool. Usually seals come with an installation tool, especially for this kind of seal. It's very inconvenient here. No chamfer, no lead in, making installation difficult without a tool. Now I'll call the supply manager and let him know the good news that I broke the seal and ruined it, so he'll need a new one. Now we just have to wait for it to arrive. Alright. If, let's say, I get it tomorrow, that's good. But if I have to wait a few days, that'll be a complete curse word. It was meant to be fine. Now, I guess we'll look for an oil seal that comes with a driver, because without a driver, it's all just really sad and disappointing. So the next day we'll only have the oil seal tomorrow. For now there's no oil seal. Anyway, I'm working on it. For now I decided to install the cover with a couple of bolts. Put the flywheel on with 3 bolts and tightened it. So now I want to set the marks, install the fuel pump. I've set the mark on the crankshaft, set the mark on the gear. Now I need to install the intermediate gear. The fuel system and injectors were repaired. The pump was tested and checked and everything is fine. Well, the customer said that the pump was supposedly repaired not so long ago. So I installed this bracket, tightened the bolts, wiped it down a bit, degreased it here. It was covered in oil and diesel, that's all. I'm currently installing the pump. So I'm installing the pump. I marked a line on the pump. So here we have a fixed mark, and on the hub itself there's also a line that I lined. That means I've also set the engine to the correct position. Since I haven't closed the oil pan yet, I'm checking by the camshaft, so we can see that both cam lobes are facing towards me on this side. That means the first cylinder is now at top dead center on the compression stroke. Then I set it to 21 degrees here, that's all. So now I'm installing the pump, tightening these 4 bolts, then installing the oil drain tube. Actually, yes, this is the oil drain, then the oil supply, and also installing the fitting for the oil drain from the turbo. And I'll also close this up right away. I think there was a valve here. I'll close all these openings, check everything, and then I'll mount the pump to the damper plates. So as we remember from Disassembly, it was set to 25 or 26 degrees of ignition timing, but now I'm setting it to 21. So I need to shift this a little bit here, Hold V. I'll loosen this bolt and move the whole mechanism relative to the shaft. It's literally just a millimeter, maybe. As for the timing mechanism, I installed a new gear on the camshaft, Hold. Put in new bolts, tighten them, Hold V, And I also installed the plate that secures them. Basically everything here is tightened up. So I installed the intermediate gear, put the bolts on the retainer, but this is the pump drive gear. I disassembled everything, replaced bearings and seals, and secured everything on the retainer as marked Mr. R. Crankshaft, intermediate gear, 2 marks. Then the fuel gear, 2 marks machine. And the camshaft, 2 marks. All the marks, the notches are aligned. So I installed the engine in its working position, installed the injectors as I showed, installed the rocker arms. First I pushed them, or I installed new ones on the rocker arm rods. So I've already adjusted the valves. The valves are adjusted exactly the same way as on the M2 866, for example. So we adjust them. We bring the first cylinder up, inverter mark, so compression, we turn it clockwise, UGK. Our intake valve won't work. After the intake valve operates, we catch the top dead center on this cylinder and start adjusting the valves, or you can turn the engine clockwise until you get what you need. Valve overlap means one valve finishes closing while the other valve starts opening at this moment. On the first cylinder, we have a situation between compression and adjustment. We adjust valves 1, 2 and 3, skip 4 and 5, adjust 6 and 7, skip 8 and 9, adjust 10. Then we turn the engine a full 360 degrees and adjust again. The remaining valves are 4, 5, 8, 9 and 11, 12. Another point, the clearance differs from the Maschinenfabrik Augsburg Nuremberg D2866, for example. The intake valve is set to 0.4 millimeters like before, while the exhaust valve is set to 0.7 millimeters. The clearance, well, apparently because the push rod itself is much longer and the valve itself is longer, so it's a thermal clearance. This results in greater clearance, as shown in literature on tappet clearance in a cold engine. Intake 0.4 exhaust. That's all. So I've adjusted the valves and now I'm going to close the valve covers. I'll be closing these covers that cover the tappet windows. And then I'll be installing the intake manifold. I'll install the compressor. I also have the filter housing prepared here. I'll install the heat exchanger. By the way, the heat exchanger is still lying over there. I haven't even washed it yet. I haven't started working on it. I also need to install the clutch basket. The new basket is lying over there. The new disc as well. I also need to install the exhaust manifold. It's on the shelf over there, already painted. See. And the starter, the installer, completely. I'll be assembling everything now, I think in another day or two, and the engine will be ready. The engine is assembled and ready to install, so there won't be a startup here. First, the engine still needs to be installed, and the repairs have taken longer than expected. The engine will likely be installed in the car tomorrow. And secondly, I still don't have the oil yet. There are reasons for that too. The oil is still somewhere on the way. So I don't see any point in waiting for the oil to start it up here and only then installing it. The engine will be installed tomorrow. The person will be working on connecting it, and there's still more than a day's work left to install and connect everything and so on. So I hope to film the startup in the car, meaning at the end of this video, I think there will be the startup of this engine. So regarding the cost of the repairs, the amount spent on repairing this car will now appear as subtitles here. But that's the total for the engine repair. The transmission repair, meaning all the parts for the engine and transmission, and all the labor for the engine and transmission. For the Volvo repair, as I mentioned, I won't take Volvos in for repair anymore. But after this car, I do have another Volvo coming in. I think that one has a different engine, if I'm not mistaken. I'll fix that engine, and after that, that's probably it. People are messaging me saying, you'll still take them, it's money after all. To those commenters, yes. I have many options with a lot of people reaching out. I probably don't even cover 5%, maybe 3% of the demand. That's what I cover, because I just physically can't take everyone's repair. So yes, I choose which engine to take for repair, which engine not to take, and so on. There are enough offers for repairing Mercedes, enough offers for repairing MANs, and so on. As for Volvo, that's a unique case on our channel. So regarding the assembly, well, obviously now everything is washed, cleaned, and prepared. So the assembly went much better than the disassembly of this engine. But still, for some things, I just don't understand how it could have been done this way. For example, there are 4 bolts on the manifold. Okay, fine, let it be 4 bolts. That's more reliable, I agree. Alright, there are 4 bolts on the exhaust manifold. But, for example, if we take the same heat exchanger, the most confusing part for me on this engine is the heat exchanger design, its mounting. Basically everything about it. So if we take the heat exchanger, for example, this is our main oil channel, the main oil line. So if something happens here, that's it. The engine, you could say, will be done for in just a matter of minutes. So we see this kind of flask here. It weighs about 5, 6 or 7 kilograms by itself, and when it's in operation, it's filled with coolant and oil, so it ends up weighing over 10 kilograms. And all of that is held by this little stud, an 8mm stud, a nut, and this kind of clamp. So this is the only mounting point for this whole assembly, this entire heat exchanger. And this same mount is also responsible for sealing these channels. In my view, that's nonsense. The mounting surface is already damaged, and this heat exchanger still moves when the engine runs. It turns out that this length here isn't secured at all, and there's still weight and vibration coming from the engine. Here the mounting surface is already all damaged. There's wear on the aluminum. The sealing happens with 2 rubber rings, and the seat for these rings is also damaged. In general, I don't know. I did install new rings, put everything on sealant, applied sealant, tightened it as much as I could, and added washers to pull the clamp closer here. Well, in any case, I don't understand the design of this heat exchanger. It would have been better if they put 2 bolts on the exhaust manifold, but here they did it in a more proper way. I think I didn't show it on the video, but I also opened it up and took it apart. Here is this oil filter housing. We have a pressure relief valve here, and there's a bypass valve as well. Well, in case, for example, the filters get clogged so that the oil can still flow into the system, bypassing the filters, there's a bypass valve installed. I removed everything, cleaned it, and inspected it. Under the filters on the block, it's probably not visible. Earlier in the video, you could see there's another pressure relief valve there as well. I also opened it up and checked it. So, I installed everything completely, whatever was there. I took off the shocks here and installed the shift lever. The engine will be installed in the car without the transmission. The transmission will be installed separately later. Well, it's better that way, it's more convenient. So, I cleaned all these air tubes, blew them out, and secured them here so they don't dangle around and get in the way for now. I also installed this bracket here which holds the filter. Here we have the air filter. I installed it mainly so I could tighten these bolts. Here we have a loop for hanging the engine. We'll need these loops before installation. Yeah. But in any case we'll have to remove it later on the spot because it's attached with these studs which I used to mount the gearbox. Alright, that means I'll be finishing this video now. That's how our Volvo engine repair turned out. Thank all for watching, good luck to everyone, see you, and stay tuned for more.
Well, it's pushing 5.